Hi, everyone. My name is Shelby, and I am a senior product marketing manager at MongoDB. And I focus on all things developer experience, primarily our programming language communities, as well as our developer tooling, and ultimately how we can connect developers to the right tools to have a great experience with MongoDB. Really appreciate being here today. This has been a great conference, and I think we've heard a lot of really interesting talks on how to kind of improve your experience working with code within the cloud development environments. And I'm here to talk to you a little bit about the data layer side of this, and specifically how we can re-envision the role of databases in cloud native development workflows. Well, so I'll start off by talking about just kind of the challenges that we're seeing in this space, explore a little bit about some of the things that developers often run into with working with local databases, talk about how at MongoDB we are using our tooling ecosystem to create a kind of very local feeling experience while getting all the benefits of working with a cloud database, and then how you can bring a cloud database together with CDEs for a more modern experience, as well as then kind of wrap up with some of the trends we're seeing in the industry and what we think is coming next. So the challenge. First, let's start with a little bit of history. We have to do everything in JSON docs at MongoDB. It's the rules. But we were founded in 2007, and we're a NoSQL database where everything is stored in JSON-like BSON documents. And our kind of core thesis and philosophy is that organizing things around documents is just a more efficient way to do things. That data that is that you access together from your application should be stored together rather than broken up into tables and columns and rows, and that having your objects in your code really map to how your data is stored is a lot more intuitive. I personally really like this. I use MongoDB when I build my fun Python projects or whatever I'm up to lately, and if you think about it, it's just a very natural way to do things. For example, if you're working in Python and you have a Python dictionary, that's basically a key value store. That maps really nicely to a JSON document. So that's kind of the core philosophy that's beneath all of our product offerings. And our core database today is available as something called MongoDB Community, which is a free downloadable version that you could download right now on your laptop here today. It's free. People really like using it for kind of quick local development, prototyping, and testing. You can also run it on-prem, can run it, Docker in the cloud. You have, optionality for how you want to run it, but you do have to manage it all yourself. We also have MongoDB Atlas, and this is really kind of our flagship product and where, our business is heading. And MongoDB Atlas was first released in 2016. It's fully managed for you, very scalable. We also, as part of Atlas, have a full text search feature called Atlas Search, built on top of Apache Lucene. Then you get technical support, performance features, and a lot of the things that you would really be looking for running a database in production. So in this talk, we're going to kind of follow the journey of a hypothetical engineer named Jordan, who is working on building an application called Weather Wizard. And they're building an app for weather analysis and forecasting. So imagine a developer who is building this cool app, and they're going to use sensor readings from a bunch of different weather stations all over the world and store them, in time-ordered collections of documents, and do all this analysis and then generate weather forecasts. There's a couple of ways that a developer like Jordan might get started with MongoDB. They might use MongoDB Community either on their local machine or on Docker. A lot of developers get started this way. They could start with Atlas in the cloud, or they can mix and match. I know, I work on a lot of things on the go-to-market side, and a lot of times we get kind of in the trap of oh, people are on Community or they're on Atlas, but actually what we've seen with our customers is a lot of times people are using both, or they use one for one thing, one for something else, maybe Community for some rapid prototyping, testing, and then use Atlas in production. Or they kind of start with one thing and move to another. So we do see a lot of cross-pollination there, because the model around being based around documents holds depending on whichever product offering you're using. So how and why Jordan might choose how to get started. MongoDB Community. Maybe they just really like having everything on their local machine, want everything isolated, encapsulated right there. Very common choice. Maybe they don't want to worry about connectivity. I actually had someone say this to me on a customer call once. I know Not everyone commutes as much as they used to, but for folks who do, maybe you have to take the Caltrain from San Jose up here to be at the Pebblebed office, and you want to make sure that you don't have to worry about tethering off of your phone to get internet connectivity. You have Community on your laptop; it's all right there. You don't have to worry about it. Or there's just kind of the hurdle of, I don't want to sign up for anything. I don't want to give anyone my email. I just want to download my tool and do my thing. Why they might choose Atlas could be, I want to have full text search, or I really want to have technical support, or I just want my data layer to be managed for me. Gives me the confidence. When I'm moving into production, I don't want to have a whole team of DBAs and SREs and have to worry about things. I just want all of this handled for me. Or it can have that kind of mix and match model that I mentioned earlier, where maybe they're going to use Atlas for something like production. They've already got their CI/CD processes running in the cloud. Use Atlas there, but still might play around a little bit with Community for some rapid prototyping. But what we found over time, talking to our customers, is that developers like Jordan really prefer that traditional local development experience, or want it to have that feeling of local development. But by working locally, developers can really miss out on the support and scale and feature set that comes from working with a managed cloud database. And the proposition I'd like to make to you all today is that as developers move to CDEs, development and testing practices working with your data also needs to evolve, because that's a really important piece of things in working with your data layer. So let's talk a little bit more about some common challenges you might see in local development when working with the data layer specifically. So Jordan's getting started building this prototype of Weather Wizard and provisioning their MongoDB instance. And they want to get started from the command line with MongoDB Community. So really simple with Homebrew or whatever package manager you're using, brew tap MongoDB/brew, a few more commands, and then you can get started. And they have a sample time series weather data set that they want to load up to start building their prototype, and really have that first kind of example of what Weather Wizard might look like, and they load it onto their MongoDB instance for coding. And everything's been going really smoothly so far, but this is where things can start to get a little complicated. They're probably going to run into a couple of challenges with local development. First one, disk I/O capacity. Because they're having this time series database, they're ultimately going to have a very high write volume against their production database, and it's really hard for them to mimic that at the local level. And what we're kind of assuming here is that you want your production and test environment and what your data looks like there to look as similar as possible to your production environment, to have everything ultimately behave the way that you expect it to. So we're kind of lacking this parity here. Storage, again, let's assume that their production database might start off holding 5 terabytes of data. It's only going to grow from there because it's a really write-heavy series of workloads. Not going to have enough local disk storage to mimic this. Sharding, because they're going to have a really high volume of data, they're probably going to want to break it up into shards, and that can be kind of complex to configure. And this is something I've heard customers mention to me, with especially folks who started on Community and then moved to Atlas. And so yeah, I started with Community, we had it on Docker, everything worked fine, and then got into sharding, it got really complicated. I really wanted someone to just handle that for me so that I could focus on just building cool features for my application. That's when I moved to Atlas. And replica sets. In this example, maybe they want to have geographically redundant replica sets for high availability and minimal server latency. Can't really mimic that just with a database on your local machine. And to be clear, I'm really talking about MongoDB as our core example here, but a lot of the things I'm talking about would hold if you were using a different database system. For example, if you were using an Apache Cassandra on your local machine versus if you were having someone manage it for you, a lot of these principles will still apply. And I would argue that write-heavy workloads like this are uniquely suited to the scalability of the cloud and having that elasticity and having everything managed for you. Let's say that Jordan also wants to add full text search as a cool new feature they're going to add to Weather Wizard. Imagine that they have meteorologists who are in weather towers in Yosemite, or avalanche forecasters in Tahoe who are writing up their reports of the snow facet readings that they took that morning. And so they want to have a feature where someone can search the text of these reports. Really big challenges in local development with if you need to have one database for your core data store and then another database as your search database, because you're going to have to set up an ETL pipeline between them, And especially once you get into production, those can be kind of brittle. And it's a lot nicer to kind of have everything in one coherent system. So I would argue that using a CDE is not enough. A CDE needs to be paired with a modern developer data platform that gives you, the full power and scale of working in the cloud with your data. Because if you're using a CDE, you're going to get all those benefits for working with your application code, but you really need to pair that with how you work with your data as well for a really fully functional, more modern experience in the cloud. So next, I'm going to talk a little bit about how MongoDB has been trying to rethink and re-envision how we can give developers a more local feeling experience, but with benefits of the cloud. The idea being that, what if you don't have to choose? What if it can feel really local, have all that kind of familiarity and comfort of, working from your terminal system on your local machine, but still get all those benefits of a cloud database. To do this, we've built a CLI tool for Atlas called the Atlas CLI. You'll notice here on the left, that's actually just the same flow I highlighted earlier on how someone could get started with community. On the right, you could try this on your laptop right now. If you have Homebrew, just brew install MongoDB-Atlas, and you can get started configuring your database in the cloud with MongoDB Atlas right from your terminal and have that flow that feels really familiar. And then some of these challenges that you might run into in local development start to go away. I/O capacity and data storage you can address really seamlessly in the cloud by having the right instance size for your cluster, or even having a serverless instance. Same thing with sharding and replica sets, where you'd have MongoDB Atlas, everything would just be managed for you, and then also backed up by a support team. And then same thing with those kind of issues with like ETL and search, because you could pair your core cloud database and have your search database just integrated as part of that. You don't have to have these separate systems that you're trying to set up. It's all kind of taken care of for you. And then while you're doing all that, you can still have optionality for testing. So assuming you're running, some suite of, unit integration and end-to-end tests, if you want to run, if maybe your unit tests don't even need to query a database at all, it's not even an issue. If they do, you could still run some high volume of unit tests against community if you really want to, and then run your integration tests against the cloud database, especially if you have any kind of search features or replica sets or sharding. It's really good to keep that really consistent by running your tests also against the cloud database that mimics what you'd be seeing in production. And then also do your end-to-end tests in the cloud. You can kind of choose your own adventure based on what makes sense for you and what's going to give you the most accurate test results. Next, I'll talk a little bit about how we can bring cloud databases and CDEs together. So one option for this would be using Gitpod as your CDE for working with code, MongoDB Atlas for working with your data. And how this flow could look is, imagine a world not only where developers maybe kind of have their own dev and test databases that they can play with that are going to mimic the production database, but imagine if they could have ephemeral dev and test databases for each pull request. And here's what that might look like. Imagine you have a monorepo. A developer opens a new CDE workspace with Gitpod or whatever CDE they're using, spin up a new cloud database using the CLI and seed it with test data that accurately mimics what the production data would look like and has the same kind of similar configuration with that database. Do a pull request for that set of code you want to work on. Do your development work, run your tests, get the test results that you're looking for, merge that data back into the monorepo, then destroy your CDE workspace and also destroy your cloud database because it's just ephemeral just for development and testing, but that really closely mimics what that production database behavior would be like. All right, so I'm going to talk next about kind of what's ahead and trends that we're seeing. So testing against cloud databases is going to become much faster, have lower latency, and just be easier for developers to use over time. Developers are increasingly going to test with cloud databases, especially for more complex and data-dependent test processes, and pair databases with CDEs for a full funnel cloud development lifecycle and CI/CD. There's going to be an AI-informed feedback loop between your database and your application. And to be clear, this isn't like a veiled product announcement. You should check out some of our upcoming conferences for official product announcements, but more of a kind of trends that we're seeing and things that we anticipate. But what's going to happen is that your things that you learn from your database are going to help you build better, smarter applications, and then things that you see in your application behavior will also help you kind of fine tune your database so these work together in a coherent, more intelligent system. And some examples of what this might look like could be identifying queries that are too slow and proactively suggesting indexes, identifying suboptimal query or aggregation syntax and recommending new syntax, guiding the user on read-write performance for indexing. In the example I used earlier with Jordan, they're going to have a really high write volume, so they might not want to use indexes. They might have to be really judicious about indexes because those are going to incur a cost in terms of how they're because they have such a high number of writes, and they may not want as many indexes. If you could have a more intelligent approach to this, it's going to help you have a better development experience and better performance in your application. It could also look like things like automatically identifying and encrypting personally identifiable information. And then ultimately, what this will result in is development, testing, deploying, and running data will become a lot more seamless, working with your code, working with your application, and developers will have a better experience and ship better code faster. That's it for me. I'm happy to take any questions. I've also put my contact information up there. Look me up. If you ever try any of our products, feel free to give us feedback. And I also put a QR code and the homebrew commands for the Atlas CLI if you want to try it.
On that last slide, you had potentially flagging long-running queries as something interesting. Do you all have an API that, say, like an in-editor coding assistant might be able to hit to get that information into other tools?
So I would love to connect you with our product team. I work really closely with them on all things around our developer tools, so I don't have anything specifically right now in terms of an AI embedded coding assistant, but as you imagine, we're looking at all of our options on the AI front, and I'd love to talk with you further about this. All right, thank you, everyone.
Okay, thank you so much, Shelby. So we have a quick break until we hit our final talks of the conference. So feel free to grab a coffee, leftover pizza, and so many snacks there. Please eat them all. We have too many. Great.